Dear students, today we are studying the topic electrostatics. The word electro means electric charges and static means stationary or at rest. So electrostatic means electric charges at rest. Hence, the electrostatics is a branch of physics which deals with the behavior of electric charges at rest. The electric charges that has accumulated on an object, it forms a static electricity. And this static electricity was introduced 2000 years back by the Greeks. And it was observed that a piece of amber, when rubbed with fur, it acquired the property of attracting small pieces of paper, straw, feather towards it. And later it was demonstrated that many other substances on being rubbed acquired the same property. And this kind of attraction is exhibited by almost all substances. That is, any substance when rubbed with something else, it acquires the attracting property. As a result of rubbing, the material becomes electrified, or they are said to acquire an electric charge. And the static electricity is created when two objects that are not good electrical conductors but are rubbed together, then the electrons from one of the objects it rub off onto the other. And one of the simplest example is when combing one's hair, and then the comb is brought near to a small piece of papers, then the comb can attract the small pieces of papers. And this static electricity has a number of applications in real world. And one of the common application is in printers and photocopiers, where the static electric charges attract the ink or the toner to the paper. And the electric charge, it is an intrinsic property of matter. So intrinsic property means it is a natural property of matter. Like mass, charge is also an intrinsic property of matter. And this charge is usually represented by the letter Q, capital letter, or a small letter q. And the SI unit of this charge is coulomb. And next is the properties of electric charges. The first property is that the electric charges are of two types, the positive charge and negative charge. And like charges repel and unlike charges attract. When a glass rod rubbed with a silk acquires the attracting property because of the presence of some charge induced in it. When the glass rod rubbed with a silk is brought near another glass rod similarly rubbed with a silk, then the two rods are found to repel each other because the charge developed in the two rods are of same type. And hence there must be a force of repulsion between the charges developed in the two rods. But if an ebonite rod rubbed with a fur is brought close to a glass rod rubbed with silk, then the two rods attract each other because the charge developed in the glass rod rubbed with the silk is different from the charge developed in the ebonite rod rubbed with fur. And hence these two objects they attract each other. And from this experiment it is clear that there are two kinds of electric charges. And later Benjamin Franklin assigned the algebraic signs to the two kinds of charges. That is, the charge acquired by the glass rod rubbed with silk is called the positive charge, and that acquired by the ebonite rod rubbed with the fur is called the negative electric charge. And this experiment illustrates that the like charges repel and unlike charges attract each other. And a simple example of a positive charge, we can consider it as proton. And a simple example of a negative charge is an electron. Both are the basic constituent of an atom. Next property is electric charge is quantized. All charges in nature, whether it is positive or negative, is an integral multiple of a basic unit of electric charge. And this basic unit is taken as the magnitude of charge of an electron. And this is 1.6 into 10 raised to minus 19 coulomb. This is the charge of an electron. Thus, the charge on any body can be represented as Q is equal to plus or minus Ne, where N is an positive integer. And this is called the quantization of electric charges. According to the quantization of electric charge, the charge on any body can be represented as Ne, where it can be 1e, 1e or 2e or 3e or 4e like that, and not half e or 3 by 2e or 5 by 2e like that. This is not the case, this is the case. Next property is that the electric charge is additive. That is, the total electric charge on a body is the algebraic sum of the charges at different regions of it. Consider a body which contains a number of charges, and let Q1 is the charge at a particular region on the body, and Q2 be the charge at another region on the body, and Q3 be the charge at another region, and Q4 is the charge at some other region. Then the total electric charge of this system, or the total electric charge of this body, can be represented as Q total is equal to this sum of the charges Q1 plus Q2 plus Q3 plus Q4. That shows that the electric charge is additive. For example, so consider a body which contains a charge 1 coulomb, 2 coulomb and 3 coulomb at different regions of this body. Then the total charge on the body can be represented as, that is, Q total is equal to the algebraic sum of these charges, that is 1 coulomb plus 2 coulomb plus 3 coulomb, and this will give 6 coulombs. And that is, the total electric charge on a body can be represented as the algebraic sum of the charges at different regions of that body. And next property is that the electric charge is a scalar quantity. That is, a scalar means a physical quantity which can be represented only in magnitude. That is, scalar means a physical quantity which can be described only by its magnitude. So here the electric charge which is represented only by its magnitude, that is either 1 coulomb, 2 coulomb or 3 coulomb, and not in terms of any directions or any other things. And the next property is electric charge is conserved. That is, the total charge, which is the sum of positive and negative charges of an isolated system, remains constant. That is, the electric charge can neither be created nor be destroyed. It can be transferred from one point to another point. For example, consider an isolated system here. This is an isolated system which contains charges 1 coulomb, 2 coulomb, 4 coulomb and 5 coulomb. If I apply some forces, external force or external disturbance to this system, so that there will be a change in the charges of the system. Here, the total charge in the system is 1 plus 2 plus 4 plus 5. That is, total will be 12 coulomb. In this case, total will be 12 coulomb. because the charge is additive. We can add this total charges. It is 12 coulomb. So if I apply a force and after that, then this 4 coulomb, this will changes. This 4 coulomb, this will change to 2 coulombs. That is 2 coulomb will be lost from this region. But the total charge in the system will remains constant. Here also the total charge will be 3 coulomb plus 2 coulomb plus 2 coulomb plus 5 coulomb. It will be some 12 coulomb. But instead of this 4 coulomb here, it changed to 3 coulomb. And the 2 coulomb charge will be, here it is created. Here the 2 coulomb charge will be destroyed in this point or in this region, and it will be created at this region. That is, the charge can neither be created nor destroyed. It can transfer from one region to another region. Here also the total charge will be constant 12 coulomb, but here a decrease in the 4 coulomb will be compensated at this point 3 coulomb. So if an object it loses some charge, an equal amount of charge appears elsewhere. That is the concept of electric charge as conserved. That is, the total electric charge is conserved in an isolated system. And these are the properties of electric charges. And the next is the point charges. Point charge means if an electric charge is confined to an extremely small volume, it is called a point charge. All charged bodies of dimensions very small when compared to the distance between them are called a point charge. All charged bodies of dimension very small compared to the distance between them are called point charges. Or any charge whose dimension is very small compared to its distance from a point where its effects are to be analyzed is also called a point charge.